Hey everyone, this is Professor Rossetti coming at you with a screencast of the groceries exercise. This is the first exercise which will help us get familiar with built-in Python data types or different kinds of objects that we have access to in Python, as well as common operations that we could perform on those data types. So our goal will be to process this information input, basically a provided data structure of grocery products, each with its own identifier and name and department and aisle and price attributes. Our goal is to process this provided information input, this data structure, into a desired information output, which is this display here. We'll break this exercise up into two different parts. The first part will focus on these products and we'll list them all in order, in alphabetical order. And then in the second part of this exercise, we'll focus on the departments. Since a single department can have many products, we'll try to get the unique departments and count the number of products per department. Sounds fun? All right, here we go. So I'm going to set up this exercise. I will create a new directory on my desktop called Python data types, navigate there from the command line, and then I'll create a new file called groceries.py. I'll place this provided data structure inside, and that will get us set up. Before I do that, I'll also create a new virtual environment, and that's from within the virtual environment, that's where we will run this Python script. All right, let's do this. I'm going to open up my terminal application. I'm screencasting from my Mac today. So, hello terminal. Where am I right now? Present working directory. Okay, I'm in my user's home directory. Let me navigate to my desktop using CD, change directories to the desktop, and here's where I'll make my new folder called Python data types, I think, mkdir for make directory, Python hyphen data types exercise, that's what I'll call mine. Enter. Okay, so now I should be able to move into that Python data types exercise directory and verifying that I'm there. Now I will create a new Python file in that directory. I'll use my text editor to do that. So I'm using the VS Code text editor, so I'm going to open it from my command line right now. I'm going to say code dot, which means open everything, all the files and folders in this directory using the VS Code text editor. Enter. All right, here we go. In this screencast, you'll see me bouncing back and forth between this VS Code editor window and the terminal window. So right now we see that we're in the Python data types exercise. There's nothing there. So I will right click and I'm going to create a new file called, groceries.py. Great. And now I will paste this code inside. So we've got this code inside. I'll just minimize the products so we can see more of the screen. We've taken a look at this product's data structure already, so I don't need to look at it right now, so I'll just minimize it. I'm going to save this file. You'll see me do this with keyboard shortcuts. I'll be Command S to save the file before I try to run it, just in case you don't catch that on the screencast. But now that I've got this Python file, we can try to invoke it to see if we're set up right. So I'm going to create a new virtual environment using the Anaconda command line utility, and from within our virtual environment, that's where we will run this Python script. So conda env list will list my existing virtual environments. I'm going to create a new one called like data types exercise or something like that. Let's say conda create n for name, and we'll give this new environment a name of like, let's call it maybe groceries-env, and I'll say yes. And so our virtual environment is created and we have instructions to activate it, which I will now do. Conda activate our virtual environment called groceries-env. Great. So now we are prompted, now in our prompt we see that we are inside our virtual environment, and we can make sure Python is installed and ask which version it is. So we have access to Python 3.7. So now we can try to use Python to invoke our groceries Python file. We say Python and then pass the file path of our Python script. So when I run this file, we expect to see output a list of our products, because in that script right now we are printing the products. So let's try it out. Enter. Okay, we see some products. Great, nice job everyone. We've set up this exercise. At this time, I would like to save our work. And so when we are developing software, there's a practice called version control that we use to save our work. And it's a little more than just saving these files we're working with. It's one step further of saying we're more sure about this version that we'd like to save. More about version control later, but you will see me now create a new repository on github.com and paste my code into that repository. And iteratively, as we develop this exercise, I'll intermittently paste my code back in my GitHub repository so that we have a running version history of our development process. And if we make a mistake, we can roll back to some previous version, and we'll talk about all the good parts of version control in next class. So I am set up here, and so we've reached a milestone in our development process. We're set up, we're ready to go. So this is a good time for us to make a commit or save a version of our exercise code. So what I'm going to do right now is navigate to github.com. And from the home screen or wherever on github.com, you should have access to a plus sign in the top right where you can say new repository. I encourage you to click that, and I'll just name mine groceries 2019-01. We'll talk about repositories and we'll talk about GitHub and Git and version control in a subsequent class, but when you're following along, just remember to initialize this repository with a README. This will allow us to manage the files from the github.com online interface, which is the absolute simplest way for us to be working with version control. And so this is the way that I'll show you now. In future classes, we'll show you perhaps more efficient ways, but they are more command line intensive or more user interface intensive with an application that you've downloaded to your computer. So we might be getting into those different processes later, but I'll just be abbreviating this version control process with you now by using the github.com online interface to create a new repository where our code will live, and then iteratively placing new versions of our code in our repository. Okay, so once we have selected this option, we can click the big green button to say create repository, and after we do so, we will see our repository on GitHub. We can navigate there. It has its own URL, and it will be under the control of your username. So let me navigate back to the groceries exercise, though, because we'll be wanting to continue to reference it. But the reason why I asked us to create this repository is I would like us to paste a version of our code there right now. We're not doing much with our code, but we're ready to start doing something, and that's a sufficient milestone. So It's a good reason as any to create a version of our solution. So from the online github.com interface, as long as you've navigated to your project repository, you can click this button right here to create a new file, and that's what I'll do now. I'll make a representation of this groceries.py file that I've created already locally in my local groceries project directory. So I'll call this file groceries.py, and then inside I'm going to copy and paste all the code that I have in my exercise so far. So after doing so, I have the option to preview my code, just FYI, but the important thing here is that once we are sure about the code that we'd like to commit or really save, we can provide a message for to accompany this version. So I might say here, setup exercise. And I'll click this green button to commit or create a new version of our exercise, our project repository here. And so after we've committed, we now see that we're viewing our repository on github.com, our remote repository, and it reflects this groceries.py file, which contains the code that we are working with. Okay, so what we've done so far is we've taken a brief detour from developing our exercise to post our code on GitHub to create a version of it and to create a repository for hosting various versions of this project. But now we're ready to get back into developing the project. So thanks for being patient as we took that detour. Now we're ready to get back into development. Let's try to remember what's going on here. We pasted in this code to our groceries.py file, we ran it, and we saw that it's working. But now our objectives are to produce a desired information output. First, we'll focus on these products. Second, we'll focus on the departments. I'd like to keep in mind something to work towards. So yes, I could keep referring back to the project description here, but what I think I'll do is copy and paste this desired information output into my Python script and comment it out, and I can refer to it within my Python script if I need to. So we want to get to this place. I'm going to comment this out. This is our desired information output. So we know that we can use the print statement to print things out to the console when we run our script, to the command line. And so we'll be printing out all these things. At this time, I could take a look at these checkpoints and do them one at a time, but I'll just be working backwards from my desired output. So we'll be taking a different approach here. You can take whatever approach works for you. I'll be taking an approach where I will take pieces of this output and I'll try to reconstruct them one by one. So I'll start doing that. The first thing I'd like to produce is this top header right here that says there are X products. So I'll probably just print the literal representation of this output. And we're using a hard-coded number of products. Let me try this out. I'm going to run this script, see if it's working as expected, and then I'll revise it. So I'm pressing the up arrow on my command line to cycle through previous commands. And so we'll be rerunning this grocery script, so I'll just be pressing the up arrow to run it quickly so I don't have to type out python groceries.py multiple times. And when I run the script, we see there are 20 products. Great. So we could be tempted to, at this point, start trying to provide or detect how many products there actually are, or we could keep moving. I think at this time, I'll probably want to say how many products there actually are. So what I'll use is the string concatenation operation to join two strings together. What I'll do is replace this 20 with an end to the first part of the string, a plus sign operator to perform the concatenation operation, and then the number that we want to concatenate, another plus sign to concatenate it with the remaining string, and then I will open up the final string here. So we are concatenating these three values together. Let's try that. We're just going to run this in small steps, and if we get errors, we'll fix them. And I think we might run into an error here, but this is a illustrative screencast, so you might run into these errors, and so by seeing me overcome them, it might help you overcome them as well. So let's try running this. We see an error. It says, hey, we can only concatenate strings together, not integers. And so this is a helpful message, and it's also telling me where in my program this error is happening. So I can now infer that there's something that I need to do in order to join these strings with this number. And we already said in class when we were demonstrating the first part of this exercise that we can change the data type of our number 20 into a string to make sure that we're able to concatenate it with other strings. These kinds of operations that we could perform on any kind of data type, we want to make sure that we're performing the operation on the right data type. So that's why we'll need to convert this to a string. If we need to figure out where these data type conversion functions exist or where a reference of these exists, I will point you to the data types document in our course repository. So from the course repository, if you navigate into notes, Python, data types, here you'll see some example conversion functions. And here we're using the str function to convert some number into a string. So we're utilizing the document on data types, and hopefully these reference documents are helpful for you. Anyway, back into the exercise though, because we're trying to overcome this error. We've converted this number to a string. Let's see if we can print it now. Great. All right, we're making progress, 20 products. We're hard coding this number 20 right now though, and what happens if we were to add or subtract products? We'd want our number to reflect however many actual products there are in here. So we'll use a variable to store the concept of our products count, and then we will display that variable in our output instead. So instead of this hard-coded 20, I'll use products count. That's a variable name that I'm choosing. Feel free to choose your own variable name. And let's just rerun the script real quick to make sure that our products count variable is getting printed. You'll see me take this small iterative approach just to confirm my own understanding of the code that I just wrote and to demonstrate that the code is performing as I expect. So you'll see me make small adjustments, rerun, demonstrate, and verify, and then I'll go back to revising the code. So, all right, this hard-coded 20 is still working, but we want to actually count the number of products. So here we have to start interfacing with this products variable. If you weren't sure already that this is a list data type, and if you aren't seeing this hint from your text editor, this little pop-up message that says, hey, this products variable, that's a list data type. If you weren't sure yet that this products variable is a list data type, what we can do is print the type of the products variable, and when we do, we'll see it, products plural, and when we do, we'll see that it is a list. So then this means we can perform any list operations on this variable. And so if we're not sure what operations we can perform on a list data type, I'll draw your attention into the document in the course repository about lists. So it's here in our notes about Python data types. Further, it's list. It's this list data type. So let's see if there's something in this document that will help us count the number of items in our list. Here I see the len function, and so I'll try using that. So I'll say len at the length function and pass in a parameter of products. So we say how many items are in this products variable. Now we'll rerun this program, and we do see there's 20 products. Let's comment out some products to see if this dynamic counting will work. So we expect now to see less products. Great, now we only see 10. Okay, nice job everyone. We're counting products using the len function. I guess I'll uncomment these lines to restore all of our products. All right, awesome. So right now we have produced this first header of there are 20 products. Great, we're ready to move on. The next thing I'd like to do is to produce this output right here. It looks like we have a line per item in our list. It's a line per product. We know that because our products variable is a list, and from consulting our reference notes about lists, we could find some notes about iterating through lists or looping through each item in the list. And we can do this using a for loop. This is a really, really common thing. So I encourage you to internalize this pattern as soon as you can. We'll say for each item in our list of items, and then we'll do something with that item. So let's try using a for loop, and we'll see if we could print each item one at a time. We'll use our text editor's code auto generation capabilities to help us out here. So we can say FO, so we'll start typing for, and then I'm going to press tab. We see that there's some code snippets that our text editor will complete for us, and that's helpful. So I'll take the text editor up on the offer to help me construct this for loop. It gives us some placeholder values, these three here, so we'll have to revise these. We're looping through each item in our products list, so we have no choice but to use our products variable here. It's in this list that each item in this list is what we want to iterate through. So we have no choice but to use our products variable here. We do have an absolute choice of what we call each item in the list as we reference each one at a time with the passing of this loop. So we could reference this as product, singular, or maybe P, or maybe like my product, whatever variable name you want to use to remember that this is referring to each item in our list of items. It's up to you. I think I'll call mine P. And so we have access to this variable P from within the scope of our loop. So we might say print P. Also, I'm not sure what the data type of this is, so we might also just want to take this time to ask what data type P is. Maybe we'll only print the data type, but the point is we'll print something about each item in our list of items. So let's try this out. Are we looping through? Do we see something printed for each of these 20 items? Let's take a look. Okay, we see now 20 things, 20 dictionary items. So we've learned two things. One, our loop is working as we hope, and that's great. And two, each item in our list is a dictionary data type. And so now we can consult our notes about the dictionary data type to see what kind of operations we can perform with each. We know that our objective here is to not print the data type of the product, but to print its name and then its price. Let's break this up into two smaller pieces. Let's try to print its name first. But how do we print the name of each one of these products? Let me provide a comment of what each one of these products looks like, just so we can visualize its data structure. This will probably be helpful. So I'm just going to comment this out. But we can reference any attribute of our dictionary by referencing the attribute name. In this case, we have attributes of ID, name, department, aisle, and price. So our P variable, or each product or any product in our list, will have these attributes. That's maybe jumping too much forward into data types, but let's go consult the reference document, dictionaries. Let's go consult the reference document about dictionaries to see how we might reference the name, for example. So back in our course repository, back in the data types notes, let's take a look at dictionaries. So here we'll find these familiar looking curly brace objects that we call dictionaries. And it looks like we can use square brackets to reference any attribute of our dictionary. So for example, these examples right here. So we'll try to adapt this example. We'll use a square bracket to reference the name of this product dictionary. So I'll say P, square bracket, and then the attribute name. In this case, name, N-A-M-E, is the name of our attribute. Let's run this and see if it works. Okay, we see these names. That's awesome. So we're starting to work with this data type of a dictionary. Excuse me. We'd like to print the product's price as well. So we're almost done with this part of our first part of the exercise. We want to give this some more human readable formatting though, not just the name, like maybe some list item bullet character, and then a space, and then a parentheses, and then a price with in USD formatting. So let's see if we can achieve this kind of output instead of just printing the name. We'll want to print something like this. I'm just working backwards with this hard-coded output. Let's try running this and see what happens. Maybe I'll just change this character so we don't get confused. All right, so here we're still iterating through each item, but we're just printing a hard-coded message. We'll want to make this more dynamic, but it looks like this representation is looking a little more human-friendly, and that's what we want. Great, let's keep moving. So we already know that we can reference each individual item by using the P variable in this case, because that's what we named our individual item in our for loop construction. So let's use string concatenation. here I'll just try to replace the name, and we'll run this. We'll hope to see what we getting further, and then we will continue to address the price part of this. Okay, now we're writing each product name. That looks good. It's looking kind of human friendly. The next part will be for us to focus on this price. So let's see if we can continue to substitute this hard-coded representation with a variable. So what we'll have here is, I'll just create a new variable called price USD, and we'll incorporate this variable in our string concatenation. Run it real quick again. We hope to see the same output. Great, great, great. But now instead of hard coding this $4.99, let's access the product's price attribute. So we can say P square brackets, and then which attribute of this dictionary would we like to access? The price attribute. All right, let's try to run this. Oops, there's a mistake. Oh, it's the same familiar string concatenation data type conversion error. So we know how to get past this. We can convert this to a string inside of our message. Let's try it out. All right. Great. So our individual product prices are making their way into our representation here, our output, but we lost the dollar sign. So we might add them back in hard-coded like this. That's an option for us. Okay, but we're not rounding to 2 decimal places. That is one of our objectives here. So this might be, we might not know exactly what to do here. Like, should we go search for a round function that we can invoke on some numeric data type? I'm not really sure. Let's go consult the reference notes about numbers, and we'll see if there's any help for us there. So back in our course repository, under data types, let's take a look at numbers. I hope these notes are in numbers, otherwise they might be in strings, so we'll take a look. Okay, so right now we want to convert a number into like USD formatting. I'm hoping the professor gave us some helpful hints here. And here we go. We could use string formatting to display how numbers will be printed. So it looks like we can try and approach like this using the format function. This is probably new for many of you, but we'll see how this works. So yeah, we know that we can access our product's price, but let's see if we can adapt this snippet that we found elsewhere. So we found this snippet and it says, okay, like, let's format this number in a certain way according to some template that we provide. Let's see what happens here if we just use this hard-coded price USD, and it should say the price is like $6.50 hopefully. But if we do see $6.50 with a 0 at the end, we'll learn that our representation of like $3.50, for example, will have that 0 on the end, and it will be in USD format. Let's see what happens here. Okay. So we're getting closer. We now see that our numbers are getting formatted as we hope, but we just need to clean up this output a little bit more. Don't be confused by single quotes versus double quotes. I probably should have made these notes more, I should have probably only used double quotes, but so I'll use double quotes now. It doesn't matter in this case. But I think what we'll do is we don't need this hard-coded like the price is blah, blah, blah. We do want to probably keep this $ representation. Maybe we can get rid of it from here. There's a lot of ways to do this. But then basically we want to put into this format any number. Which number? Well, no longer the hard-coded 6.5 that we saw came through into all of our products, but we want to take the actual product price. So let's try to format the product price, each dynamic product price instead. And the only way we know if this works is to try it out. All right, so that's looking pretty good. Nice job, everyone. We've used string formatting to convert a number into a string, but also specify the type of formatting template to use during that conversion. Things to do with strings, the most common I'd say are concatenation, which we've been practicing, and also maybe converting an integer into a string using the format function. And we'll take a look at different shortcuts for using this format function, but in the meantime, right now, we'll use it in this way. All right. Alternatively, you could put all of this inside your formatting function by formatting your number. The return value will be a string, so we could move these parentheses into our format if we want. So we could do all of this with an easier representation. As you're developing these projects, as long as you've got something that works, feel free to stick with it. I'm showing you a few different options now, so that you might benefit from knowing about them. Let's see if this will work. All right, cool. So here I'm just demonstrating that we can maybe format our number in a more succinct way. Okay, finally, let's move on because we're pretty much done with this first part of our exercise. We still haven't sorted yet though, so that's the final aspect of this exercise that we'll work towards. But this is looking good to me, and it's a lot closer to the final solution than we had when we started. So I think this is a kind of milestone. So let's take this time to save a version of our project or commit our code or post it to GitHub. We'll overwrite the code that we have on GitHub to reflect the development progress that we've made. So let's take a quick detour. I'm going to navigate back to my project repository on github.com. Here it's groceries 2019-01. And then I'll navigate to my groceries.py file. And then I will locate this pencil-looking icon in the top right. This icon will allow us to edit this file using the github.com online interface, which is, I think, the easiest way to teach you how to use GitHub to start. So I'm just going to get rid of all the code in there, and I'll now copy and paste all the code from my script into my remote repository. Don't worry if there's some commented lines of code in your submissions. Its comments are there for you to use to help you, and you won't be graded down if you have comments. In fact, often comments are helpful, a helpful way for you to communicate with yourself over time, communicate with other people. So don't worry if you have comments in your program. All right, so I will maybe preview these changes. And here we see like a rich preview of what changed. It looks like these red lines are what got removed and these green lines are new. And that reflects my understanding of the changes that I've made. So at this time, I will confirm these changes. I'll say then my commit message here will be display each product. You can choose whatever message makes sense to you. And then after pressing the green button to commit these changes, we should see them reflected when we visit our file on GitHub. And we do. All right, great. So we have committed our code. We've saved another version of it. And one quick thing to show you is that from the root directory, I guess, of our remote repository on GitHub, we could take a look at the commits, and we'll see our version history here. So here is the commit where we created the repository. Here's a commit about a half hour ago where we set up the exercise. And here was my commit a few seconds ago where we were displaying each product. So if we wanted to take a look back in time on any version, we can do that. We could roll back to any version. More about version control later. Okay, anyway, the point is we have committed our code and we're ready to further development of our groceries project, or exercise, I should say. All we need to do now is sort these items. This is the hardest part of the first part of this exercise. So our question now is, how do we sort a list of items? If we have a list of integers, this will be easy. We can use an object-oriented approach to call, I believe, .sort on that list. But since we have a list of dictionaries, we'll have to use a more complicated solution. So let's take a look back at the document on lists, and we'll see if there's anything about sorting in this document. And luckily there is. That's great. So this is what I was just talking about. If our list was just of simple numbers, we can call sort on the list and we'd be done. No need to go into the rest of what we're about to go into, which is maybe a little complicated. But since our list is a list of dictionaries, we have to specify how Python should sort our list. We have to provide what is essentially like a function to say that given any item in our list, on what basis should we sort this item? On what value should we sort all of these items? But specifically, what we're going to do is use a built-in function called sorted. We talked about this in last class, so I won't go over it in too much detail, but basically the parameters that we need to pass to this sorted function are two. First, the list that we'd like to sort, and second, the way in which we'd like to sort the list. Specifically, the way in which we'd like to sort the list should be a function that accepts as an input one item in the list, and as an output returns the way we'd like to sort, or the value in which to sort on. Okay, so we can try one of these approaches up here using our own custom function and passing that to the sorted function. There are shorter ways that we can do this, but we haven't yet talked about importing modules, so I don't want to get too far ahead of ourselves. But what you can see here is that it's possible for us to do this in a more concise way, and if you'd like to explore this way, I encourage you to do so. But as a more basic way, I'll share with you how we can define our own custom function and pass that function as a parameter to our sorted function to tell it how we'd like to sort our list of products. Okay, that was an introduction into using functions to sort our list of products. Let's try it out. So we'll want to use the sorted function here. Thanks, notes. We heard in class that we'll want to do the sorting before we actually loop through our products, because if we sort them after, they won't be sorted when we print them. So I'll do it up here. We'll say products, or I guess let's call it sorted products equals, we'll use the sorted function, and it will take two parameters. One is the list to be sorted, in which case for us is our products list. Second, the way to sort it, we'll say our the name of this parameter is key. So you'll see us sometimes specifically reference the name of parameters in our invocation of the function like this, like key equals something. So don't be confused if you see that. We're just passing in the second parameter here. And here I'd like to sort by name. This is not yet anything, but I'd like to now create a function that will be called sort by name that will take as an input any item in the list and return as an output the way we'd like to sort, in this case by the product's name. So let's say def. Def is the way we define a new function in Python. We've been using a lot of custom functions, built-in functions, but we can also create our own functions using the def keyword. And I just pressed tab and our text editor did some autocomplete to help me out. So here we get to specify the name of the function. I said we should call this sort by name. Inside the parentheses, we specify what our input parameters should be. This is not required, but if we are using a function for the purposes of passing it in to the sorted function, we do need for this function to accept any item in our list. So here I could call it P maybe, using the same kind of concept to reference a specific item, specific product item in our list. Don't be confused about me using P here and me using P here. These are actually separate usages of this concept, although the concept is the same. One item in our list of items. Maybe just to differentiate here, I'll call it like any product, something like that. And so inside our function, indented, this is where we specify what should happen when this function is invoked. And here we say return the product's name. And so this is how we will sort. We'll sort this list of products on the basis of each individual product's name. So let's try this out. We hope to see these products sorted, although we're still listing this non-sorted version of our products list. So let's actually use this sorted products variable here. We'll loop through the sorted products instead of products. Nice. All right, we see the products sorted. We're officially done with the first part of this exercise. And I think this is such a big milestone that I'd like for us to commit our code again. So what I'll do is quickly copy my code from my text editor, and I will navigate back to my project repository and the groceries.py file inside, and I'll edit the file. I will remove all contents of it and paste all the contents again. I'll do a quick preview to see the changes. Okay, we see this new section about sorting. Looks good. So I will specify a commit message of sort products, and then I'll commit. Nice job, everyone. We're done with the first part of this exercise. I've talked about the concept, so that's why this has been a little longer than it would have taken as if I were just kind of developing it, but I hope that this narration is also helpful for you. All right, so we're 50 minutes in and we're ready to start the second part of this exercise, which is focusing on departments. So let's think about this a little bit. We know our products each have a department. And so our job now is to somehow assemble a list of unique departments such that we can say how many there are and we could loop through them. You could think of a similar process is what we just went through. We said, hey, there are X number of items in that list, and then we loop through each item in the list, and we printed out the name of that item. So we'll want to do something similar. I guess to get us started, let's just see if we can print how many departments there are. So I'm going to clean up a little bit. I'll make some sections, just some organizational structure in my code. I'll say like products, part 1, and here's some code about that. And then I'll give myself a section for departments. This is part 2. So now we can focus on writing some code here. Like we want to print this header. So we'll do something similar as what I did the first time in printing this hard-coded representation. Let's run this and take a look. All right, we see there are 10 departments. We already know that we're printing the products fine, so I'll probably just comment that out for now and restore it later. We did some abstraction before of counting the number of products and using a separate variable, so let's do that again here. So I'll slowly, step by step, do this. Oops, we're running into our data type conversion error again, so we'll convert this number to a string so we can concatenate it. All right, we're looking good. Let me comment this out as well. All right, so forget all this product stuff. Let's just focus on departments right now. I'm just going to continue to organize this code. Like, here's what we wanted there. And here's what we want for an output at the bottom. Excuse me, for our second part, for our departments. All right, just cleaning up this script a little bit so I can make sense of it. What are we doing? We're saying there are 10 departments, great. But let's abstract this department count away into its own variable. Rerun this. All right, it's still working. That's great. Now comes to the hard part. How do we count these departments? I guess above we counted products, we had a list of products, and we were able to use the len function. So I'd like to see if we could use that approach as well. So we'll probably say like the length of some list. Like maybe we'll call it departments. But now we need to actually assemble this list. I'm not sure what to do yet. I'll just create an empty list and rerun the program and see if we're still on the right track. All right, yeah, there's 0 departments because we have an empty list. So now our question is, how do we assemble this list of departments based on this list of products? Here's where you might you might focus on the conceptual approach and just try to think through what we might do conceptually. It seems that if we can access each item in the list, like we can print its name and print its price, we could probably print its department. Okay, so we can maybe loop through all these departments and do something with each department. That's probably where I might start. And corresponding with that, I'll share with you some information from the notes about lists, and you'll see how this comes into play. So let's take a look back at our notes about lists, the list data type. You might not know what this is called or how to search for it, but the word that I'm using to describe this process is filtering, where we want to actually, where in the notes? I think an iteration, okay, backing up. We already talked about iteration and iterating lists. We already used a for loop to iterate through them. Another common pattern is to, as you iterate through your first list, to assemble another list based on the values of that first list. And so we'll use a pattern like this. There are other ways to achieve this pattern where we're assembling one list based on the contents of another list. You could use the map function. You could use a list comprehension. We'll talk about this next class, but to use the simplest way, I think I'd like for us to just use this this approach where we're going to iterate through our list of products and somehow assemble this list of departments. We'll key in on using the append function or the append operation to add a new item to a list. So let's see if we can adapt this to meet our use case. We'll want to iterate through a list of products to assemble a list of departments. All right, we might have to take this in a number of steps. So we could use our sorted products or our normal products. It's up to you. I don't think it will matter for this purpose. I guess we might as well. It doesn't matter. I'll just keep on using our products variable in case maybe we made a mistake or something during the sorting, but they will be equivalent. All right. So this departments list is empty. We need to populate it. Let's see if we could figure out how to do that. Adapting this approach we saw in the notes, we might use another for loop to loop through each product in our products list. And then instead of printing, well, I guess let's just try to start by printing the department. So like, could we print p.department? Do we have access to this? Let's see. Okay, we're printing all the products. That's great. We see some duplicates. We'll figure out those later. The lesson here, though, is we'd like to use the append operation to add those new items to our list. There's a few approaches we could take here. The easiest one, I think, is to say departments dot append. Here I use a dot to say that we're about to invoke some method or property on this departments variable, and we see our text editor helping us out. Like append, okay, append is one of those methods or properties. Let's see more information about append. Okay, it looks like the object that we have to pass into this append operation is the object to append to the end of our list. Okay, that was helpful. So what do we want to append to our departments list? I guess the actual products department. So what this will do is loop through each product, and for each it will assemble the list of departments. It will append or add the products department into our list of departments. Let's try this out. There are 20 departments. Okay, what are they? Let's loop through them. For P in, oh, I guess for maybe D in departments. Print that department. Let's see what they are. Okay, great. We still have some duplicates, so we'll want to remove those duplicates. There's a few ways we can do this. We can use our inclusion operators to only conditionally append the department if it doesn't already exist in our departments list. So we might use a if statement here to say, like, if the products department exists in our departments list already, or I guess if it does not exist in our departments list already, then we can append it conditionally, where you'll find you'll find information about these inclusion operators in the course notes. We've seen operators like double equals, like is what's on the left equal to what's on the right, or not equal to is what's on the left not equal to what's on the right, and we could also use inclusion operators like is what's on the left in what's on the right, or is what's on the left not in what's on the right, and these will all return either true or false. We'll work with these operators more often, but in and not in, just FYI, we can check to see whether one item exists in another item. Let's try this approach out. We hope now that by only conditionally appending the department to our departments list, if that products department doesn't already exist in the list, we hope to assemble a unique list of departments. There's another way we can do this as well, but we'll see how this works. Okay, great. 10 departments. We have uniquely identified them. That looks great. I think I would like to take this time to commit my code because we're doing something. So I'm going to copy it and go back into my remote repository, my groceries.py, and my remote repository on GitHub. Let's edit this file and overwrite its contents. We can preview those changes. Let's see what we just did. Let's see, might have removed some of that code, or I actually just commented it out and added some stuff about departments. Okay, so what did we do? I guess we assembled list of unique departments. Nice, we're crushing this exercise. Nice job, everyone. Let me show you an alternative way that you might do this. We could go back with our approach of appending all departments into our list of departments, in which case we'd see that long list of departments, including duplicates. There's a certain data type called a set that allows us to convert a list to it, and when we convert a list to a set, it will remove duplication. A set data type doesn't allow any duplication of terms, whereas a list does. And so if we convert a list to a set, it will just remove the duplicates from our list. And this is a helpful technique that I'd like to share with you. You see, we already used a conditional logic approach using an if statement to arrive at our unique list of departments, but this is an alternative approach that I think you might find helpful in the future as well. So let's see, these changes give us our list of 20 departments. Okay, these are non-unique. We need to make them unique. So what we might do now is, before we count and print these departments, we might say, what do we want to do? Remove duplicates by converting to a set data type. So we can say departments, or maybe we'll say unique departments equals set of our departments. So this departments variable is a list. We see that here. When we convert it to a set, it will be of a set data type, and then after we'll have to convert it back into a list. So we'll do this all in line like this. Take departments, convert it to a set, take the result, convert it back to a list. So now if we count our unique departments and iterate through our unique departments, hopefully we'll see our unique departments, and we do. Nice job, everyone. So here we're using two different approaches. We could use conditional logic to only append an item into this empty list of departments if it doesn't already exist in there. Otherwise, we could not worry about the conditional logic when we append all the departments into this departments list, and after the fact we can remove duplicates by doing some data type conversion. All right, so this does work. Let me quickly just commit this code. So I will copy and paste it into my remote project repository again. Looks like there were some changes about assembling those unique departments. Looks good. I'll say alternative way to assemble unique, remove duplicates. Departments. Great. We're almost done. Let's just make this list of departments look the way we want it to. I guess we want to alphabetize these and also title case them. So we can say d.title to convert it to title case. If you're not sure where a reference for that was, you could take a look at the strings document. Let's take a look right now at our strings document. So, oops. All right, let's take a look at our strings document. Back in the notes about data types, strings, and here we'll find some examples of converting the case of these. So we can convert to uppercase or lowercase or title case, and here we'll want to convert to title case. All right, let's try this out. Nice, title case, great. We want to sort these. So luckily, because this list of departments is just a list of strings, essentially it's a list of department names, we could just call sort on it. So let's do that now. So this is a mutating operation. It sorts in place. So hopefully this will sort our list of strings, and we'll see them in alphabetical order here. And we do. Great. So we've sorted this list of strings, and we're almost done. The final step will be to try to count how many products correspond with each department. So let's do that. Before we do, I'm just going to create another version of this project. I'm going to overwrite the contents of this groceries.py in my in my project repository on GitHub. Looks like we're sorting the departments here. So I'll say like sort departments, sort and format them. Great. So just creating another version of my program, but our objective now is to count how many products are associated with any given department. This is maybe the hardest part of this exercise, but a very instructive aspect of the exercise. We'll want to think about an operation called filtering. So here, what we'd like to have happen is, I guess, right now we're listing these departments, but we'd also like to know how many products. So let me just prepare to set up a display that will tell us how many products we have. So I guess here I might hard code, I might do some string concatenation like this. Let's see if this works. All right. I will probably want to put a space in there too. Okay, not bad. We're saying that there's X number of products, but now we need to just count the actual number of products. So let's abstract this concept into its own variable. Maybe we'll call it product count. Sure, why not? Actually, we'll call it something else. because I think I used product count elsewhere. I think I used it like, products count. Just to be safe, I'll say matching products count. So here we'll want to assign a value. All right, let's try running the script to make sure we did our string concatenation right. Uh-oh. All right, we have to convert this integer to a string in order to concatenate it. You would think I would remember to do that by now. Anyway, okay, so we're ready to say how many products are associated with each department. We have this variable called matching products count. So we'll want to somehow now take our department and see how many matching products there are. So let's take a look back at the notes about lists. Conceptually, what we want to do is, given any department, count the number of products that have a matching department. Let's take a look back at our notes about lists and see if there's anything in here to help us out. All right, back in our notes about lists, the topic or the operation that I'd like to draw your attention to here is called filtering. So when we filter a list, we select some subset of it. Perhaps only a single object that meets some criteria, or perhaps many objects that meet that set of criteria. But what we want to be doing is specifying which lists we'd like to filter, and also the condition for filtering it, or which items should be returned as matching this filter logic. So we could use the filter function to do this in Python. It looks like it takes similar parameter inputs as the sorted function, but maybe like reversed. It looks like the parameter inputs it needs are first the way to filter the list, and then second the actual list. So we might use the filter function. At this time is where I'd like to introduce you to one of my favorite constructions, or one of my favorite tools available to us in the Python programming language. It's called a list comprehension. So you could take a read through these notes, and you could try out some of these various approaches, but I would like to share with you a list comprehension because it's very versatile and flexible, and we'll talk about them more in future classes and how I learned about them. But because they're so powerful, I'd like to take this opportunity now to introduce you to them. So we can use a list comprehension for filtering purposes like this. If we have a list, for example, a list of dictionaries, we can specify some syntax here that will say which items in that list to return. We can also optionally transform the items or map them, but we won't be doing that right here. We'll just be taking a look at the filtering part of this list comprehension technique. So what we see here is that our list comprehension starts with a square bracket and ends with a square bracket. And then we have some kind of similar for loop looking construction. We have for some item in our list of items. So the way we read this is that we can say return some item. Here's where we could transform the item further if we want. We'll talk about that later. But if we just want to return the item itself, we can just reference the item itself here. Anyway, return the item for each item in our list of items if that item matches some criteria or condition. So this syntax, yes, it's really scary. There's it's it might not be the most familiar to you right now, but there is a pattern here, and I encourage you to try to pick it up. We'll be using list comprehensions much more in previous classes, but we'll use it right here for filtering purposes. I think this will become a little more clear when I illustrate this to you. So let's see if I could copy and paste this, and we'll try to adapt this code, this list comprehension. The place we'd like to do this is probably right here. We can say like matching products, or some filtered list equals, I guess, some list comprehension. And then here we could take the length of our matching products. So what we'll want to do is use a list comprehension to identify how many matching products there are, or actually identify which products are matching. So we're not working with teams, we're working with products. So let's take a look at this for loop that we use for products. We'll probably use a similar syntax. For each item in our list of items, we know our list of items is our products list. So we have no choice but to use it here. Now we have the same choice about what we call each item in our list. I'll just call it P in all of these places where we're going to refer to any individual item. So for each item in our list of items, return that item if the item's department is equal to the department name that we're interested in right now. So we see right now we printed out these departments one after another. So we're working with departments like babies, for example. So what this code will do is it will say, for each item in our list of products, return that entire product dictionary if the products department is equal to babies, or whatever department name we're working with in our loop. All right, so I know that's maybe a little confusing, but let's try it out and see if it works. It's a powerful technique. Sweet. So we're counting, it looks like these numbers are different. We're almost done. Just check them out. Let's do a sanity check to make sure there's only one product with babies and 5 with beverages. So we'll examine our products list. Babies, I see it once. Beverages, I see it 6 times. Oh, but only 5 times because I'm using it once down here. All right, that looks good. Oh, and also the output that we're working towards does say 1 and 5. Okay, so we checked our output. It's looking like we want it to do, except the final part of this project will be to conditionally say whether this is a single product or multiple products. So let's do that last, but we just did something really significant. We identified how many products were matching each department. So you guessed it, I'd like to take this time to commit our code or save some version. So I'll copy and paste my code back into our remote project repository. Let's take a look at the differences. All right, we're just using a list comprehension to assemble or identify the matching products. Then that's going to be a list of matching products, and then we're counting each one, and then we are displaying that count in our representation of these departments. Okay, so what are we doing here? Find matching products. And I'll commit. We're almost done. One more final step in this process is to conditionally pluralize the label of product versus products. So there's probably a built-in way to do this using some package or module. So actually let's search for one right now on the internet for fun. If we don't find one, we can use conditional logic to say if there are more than one matching product, then we'll use the product label, else we'll use the products label. Actually reverse that. If there's more than one, use products, else use product. And actually, instead of searching online for some other way to do this, I'll actually just use that simple conditional logic because I think that will be um, helpful or the least intimidating. Let's do it. So here, we either want to say product or products. So I'm going to abstract this concept away into a variable called label. And if we use a hard-coded products, let's see this. Let's see if this is working. Nope. String concatenation issues. All right. Now it is working. We have abstracted this concept away into its own variable. And here's where we can use some conditional logic to set its value. We could say if some condition is true. I guess if our matching products count is greater than 1, label equals products plural. Otherwise, our label will be product singular. For 0, I guess it would be products, so this would work. Let's try this out. Matching products count? Oh, make sure to spell your variables right. Sweet. 1 products. Oh, 5 products. Uh-oh. What's going on here? Greater than 1? If it's greater than 1, label as products. So why is 1 product? Let's do some debugging. I will share with you how are we going to do this debugging? What's wrong with this right now? If matching products count is greater than 1, our label is product. Oh, okay. Else product singular. My bad. So you might make mistakes like that sometimes, but I guess I just reviewed my code and I found what the issue was. I was saying products in both cases. Let's try this again. Nice. So now we see the conditional display either product or products. And I think we're ready to package up this project. We'll want to add some formatting to how we're printing these departments. And we'll also want to restore our printing of the products. And after we do that, we hope to see an output that resembles our goal. And we do. So, nice job, everyone. Thanks for following along. Let me know if you have questions in Slack. Otherwise, I'll see you next time. Peace. Oh, wait, before we go, let's commit our code. Don't forget, we'll commit our code. So, finally, making our final commit. Preview the changes. Restoring some printing, conditionally matching, conditionally assembling a label. Okay, that looks good. I guess we should say, what are we doing? Conditionally pluralize products count label, something like that. All right, so now we're really done, and I'll see you later.